Hello, all. In this class, we'll discuss the applications of AI in manufacturing industry. So basically, AI is used in manufacturing industry, financing the efficiency, can reduce the cost, can improve the quality, can take some decisions, smarter decision making, manipulative, and basically, it is useful for entire manufacturing value chain, from design to production to supply and manage supply management and maintenance part. So look at the some applications related to this part. So first part is predictive maintenance. Okay. So basically AI uses AI use the machine learning to predict the equipment failure before they occur. Now it can minimize the downtime, it can maintain the cost. So we have different sensors on machine. Already we discussed this part of data collection like your temperature sensor, pressure sensor, vibration sensor that is used to collect the data. Then AI model can analyze the defect, or we can say science software. Suppose is there a failure in the component. Again, we can use some machine learning algorithm such as time series analysis or anomaly detection, process historical and real-time data when machine is likely to fail. Okay. Now, what are the benefits or why people are implementing this part? So important is it can reduce the unplanned downtime by 50% as per the industrial case studies. Then it can extend the equipment lifespan by addressing the issues of the, so it can lower the maintenance cost by avoiding the unnecessary repairs. So these are the advantages why people are implementing this AI into predictive maintenance. Now, to take example of General Electrical that uses AI-based predictive maintenance in its wind turbine to optimize the performance and it can reduce the outage. Okay, so again, Siemens employees are using AI to monitor the industrial equipment for predicting the failure in motors and turbines. So these are the basic examples where different industries are implementing AI for predictive maintenance purpose. And by implementing this AI for various industries, it is helping that industries to lower the maintenance cost, to reduce the unplanned downtime, and to address the issue early so that we can extend the equipment lifespan. That is the advantage. Now, just look at the flow, how they are doing the predictive maintenance, or how we can monitor the equipment conditions. Okay. Now, what we have some sensors which are mounted on the machine. Sensors are taking real-time data. Now, that data will get sent to cloud. Okay. Now, at cloud, what will happen? We have some historical data related to that machine failure. It can compute that particular value. And if there is any failure is occurring in some period of time, then so that information will get sent to that particular maintenance specialist. Okay. And then that maintenance specialist can take the decision. Second part is there how that information will get transferred to shop floor worker. We have some dashboards. So based on that data, again that information will get sent to dashboard of that particular worker so that they will get idea which machines will go to fail in uh, their routine time or routine operation time. Okay. So in this way, this systems is useful. This AI is useful in predictive maintenance. Then second, we have quality control and defect detection. Okay. Now basically AI power computer vision systems that is it is using some we have image recognition part of suppose say for computer vision systems we can detect the product or we can inspect the product for defects. We can ensure the high quality and consistency. Okay. Now this system can detect flaws that are difficult to human estimate. Like suppose say take for example a bearing. On bearing, there are small cracks are there or small. Suppose there is some scratch or wear is on that bearing. On normal human, it is quite difficult to analyze this particular wear and tear on bearing. But easily we have some AI-based vision systems where that camera can detect the object and based on their pattern recognition, so we can say that whether that object is defective or it is okay. That idea can be get. Now, this system is using deep learning models. Particularly, we can see it is working on CNN, convolutional neural networks part that can analyze the image or videos from production line. It can identify the defects like scratches, misalignments, or contaminations, and it can classify the product as pass fail or we can say a flag items for further inspection. Okay. Now, what are the advantages of this particular part? Now, this AI improves the defect detection accuracy by up to 90% compared to manual inspection. It can reduce the scrap and rework cost. It enables real-time quality monitoring. It can minimize the defective product shipments. Like suppose if you take example of BMW. Now BMW is using AI vision system to inspect the weld and surface finish on car bodies. Now, whenever there is a painting on that car body, they are taking that photo and they're checking the finishing of that particular paint on that BIW part. The second is Foxconn employs AI to detect the defects in electronic components during the assembly. Okay, so these are some examples where people are implementing this AI for quality control and defect detection. Okay, now look at the flow, how this system is again checking this part of quality control or how it is useful in quality control. Now again we have some sensors. Okay, we have some data related to machine health parameter, ambient parameter, and its calibration. Now just put, I have already told you, it has some standard values of parameters. Like suppose if we're talking about surface finish, if we're talking about roughness, if we're talking about the finishing of that paint. Now all this data will get collected. It can detect or it can compare with the desired parameter, and it can identify the source. So which part is fail or where there is any dent on a particular paint is there or whether any scratch on paint is there. That information will get sent to particular technician or particular operator, software operator. So this is the overall flow, how that machine is useful to analyze or detect the failures or to detect the defect in the component. Okay. Then next part we have process optimization. Now basically again, we optimize the manufacturing process by analyzing the data. It can identify the inefficiencies, or it can adjust the parameter. Okay. Now we have some reinforcement learning or optimization algorithms that analyze the data from production line. Like you can analyze the cycle time, energy usage, material flow. Like suppose to digital twin. Digital twin means we are virtually replicate that physical system. We can simulate the process and we can take the optimizations. Now this importance of this AI in process optimization is it can increase the production efficiency by 10%, 10 to 20%. It can reduce the energy consumption and waste. It can enable adaptive manufacturing where process adjust dynamically for changing conditions. Like if you take example of Tesla. Okay? So Tesla is use the AI to optimize the battery production process. It can improve and reduce the production cost. Similarly, BSF employs uses AI to find clean chemical manufacturing process by minimizing the resource use. Okay. These are the one part where people are implementing this AI in process optimization. Then for SCM, now again AI enables supply chain efficiency by forecasting demand optimizations and improved logistics. So we have some machine learning models out there. They are taking historical data, market trends, and external factors like weather or geopolitical events, predict the demand. Okay. Based on this part, this algorithm, genetic algorithm, they are getting idea about the future demand or market demand. Now, what is the advantage? It can reduce the inventory cost for through the better demand forecasting. It can improve the real time, reduce the logical cost. It can enhance the resilience to supply chain disruption. Like we have some Procter & Gamble's that uses AI to optimize the global supply chain balance in the inventory and production cycle. Again, Amazon's are using AI-driven supply chain system that supports the manufacturing and fulfillment of operation. Look at the flow. Now, in case of SCM, again, based on the requirement, like suppose if you are using this AI for logistic part or ELS part, okay. Now, based on the requirement, how this systems can detect the requirements. Suppose what we have, they have just compared the issues related to manufacturer and how that manufacturer will send the information. Suppose that data is related to defect or temperature or cooling rise is there. Okay. Now, how that system can be reset for warehouse operation and how that notifications will get sent. Suppose the IoT solution is having issues related to transport management system. Okay. Then that it is follow some optimized vehicle route. Then suppose there is issue of early maintenance forecast. Suppose there is issue of distribution chain. Okay. Now that part is there. So based on this demand, based on this market conditions, people can take appropriate decisions related to delivery. Okay. So this is all about these applications of AI at various industries.